Have you ever looked up at the night sky, filled with countless stars, and wondered where it all came from? How did this vast, incredible universe begin? And what's our place in this cosmic story? Well, today we're going on an epic journey. A journey spanning billions of years to tell the greatest story ever told. The story of our universe. Our story begins with a bang. Not a bang in the sense of an explosion in space, but the explosion of space itself. About 13.8 billion years ago, everything we know, all matter, all energy, all of space and time was compressed into an infinitely hot, infinitely dense point called a singularity. Then, in a fraction of a second, it began to expand. This was the Big Bang. In the first moments after the Big Bang, the universe was an unimaginable inferno. It was a chaotic soup of fundamental particles and energy, expanding and cooling at an incredible rate. It was too hot for even atoms to form. Just seconds after the beginning, the first building blocks of matter, protons and neutrons, started to come together. For the next few 100,000 years, the universe remained a dense, glowing fog. Light couldn't travel freely. It was constantly scattered by charged particles, like sunlight in a thick mist. The entire cosmos was opaque. Then, about 380,000 years after the Big Bang, a crucial event happened. The universe cooled down enough for protons and electrons to combine and form the first neutral atoms, mostly hydrogen and helium. Suddenly, light was set free. For the first time, photons could travel unimpeded across the cosmos. This ancient light is still visible today as the cosmic microwave background radiation of faint, uniform glow that fills the entire sky. It's the oldest light in the universe, a baby picture of our cosmos. After this, the universe entered a period known as the Cosmic Dark Ages. There were no stars, no galaxies, just vast clouds of hydrogen and helium drifting through the expanding darkness. But gravity, the silent architect of the cosmos, was patiently at work. Over millions of years, it began to pull these gas clouds together. Denser regions started to attract more and more matter. As these clouds collapsed under their own weight, the pressure and temperature at their core skyrocketed. Eventually, it became hot enough to ignite nuclear fusion. The first stars were born, ending the cosmic dark ages and lighting up the universe. These first stars were giants, hundreds of times more massive than our sun. They burned fiercely and lived short, spectacular lives. When they died, they exploded in cataclysmic events called supernova. These explosions were incredibly important. They forged heavier elements inside their fiery hearts: carbon, oxygen, iron, all the elements essential for life, and scattered them across the cosmos. These elements became the raw materials for the next generation of stars and planets. Our universe was enriching itself, creating the very stuff we are made of. Over the next few billion years, gravity continued its work, pulling stars and gas clouds together to form the first galaxies. These early galaxies were small and irregular, but they merged and grew over time, creating the majestic spiral and elliptical galaxies we see today, including our very own Milky Way. Inside these galaxies, countless generations of stars were born and died, each one further enriching the cosmos with heavy elements. About 9 billion years after the Big Bang, in a quiet corner of the Milky Way, a new star began to form from a collapsing cloud of gas and dust enriched by previous supernova. This star was our sun. In this disk, tiny dust grains started sticking together, a process called accretion. Clumps grew into pebbles, pebbles into boulders, and boulders into planetesimals. Through countless collisions and mergers over millions of years, these planetesimals eventually formed the planets, moons, and asteroids of our solar system. One of these newly formed planets was Earth. Early Earth was a hostile place, a molten ball of rock, bombarded by asteroids and comets. But these impacts also delivered crucial ingredients, like water. Over time, Earth cooled. A solid crust formed, and oceans began to cover its surface. The stage was set for the next incredible chapter in our universe's story. The emergence of life, around 3.8 billion years ago, in the warm, chemical-rich waters of the early oceans. Something miraculous happened. Simple organic molecules combined to form self-replicating structures. Life had begun. At first, it was just simple, single-celled organisms. For billions of years, These tiny microbes were the only life on Earth. But they were busy. Some evolved a process called photosynthesis, releasing oxygen into the atmosphere and fundamentally changing our planet's chemistry. This new oxygen-rich atmosphere paved the way for more complex life about 540 million years ago. The Cambrian explosion occurred a relatively short period where life suddenly diversified into a stunning array of complex forms: fish, insects, amphibians, and eventually, the dinosaurs came to rule the Earth. Then, 66 million years ago, another cosmic event changed everything. An asteroid roughly the size of a mountain slammed into the Earth, causing a mass extinction that wiped out the dinosaurs. While it was a catastrophe, it created an opportunity. With the giant reptiles gone, small mammals that had been living in the shadows began to thrive and diversify. Among them were our distant ancestors, the primates. Over millions of years of evolution, driven by changing climates and environments, a new kind of primate emerged, one that could walk upright, use tools, and develop complex language. This was humanity. We are the product of 13.8 billion years of cosmic evolution. The hydrogen in our bodies was forged in the Big Bang. The carbon, oxygen, and iron were created in the hearts of long-dead stars. The story of the universe is not just something that happened out there. It's our story. And the story isn't over. Our universe is still expanding. And intriguingly, the expansion is accelerating. A mysterious force we call dark energy seems to be pushing everything apart, counteracting gravity. What is the ultimate fate of our universe? Will it expand forever, becoming cold and empty? Will it reverse course and collapse back in on itself in a big crunch? Or is there another destiny we can't even imagine? We don't know for sure. But what we do know is that we are part of an incredible, ongoing cosmic drama. We are a way for the universe to know itself. Our curiosity, our ability to ask these questions and seek the answers, is one of the most remarkable things the universe has produced. So the next time you look up at the night sky, remember this story. You are not just looking at distant points of light. You are looking at your own cosmic history, at the ancient fires that forged the elements you are made of. You are a part of the universe, and the universe is a part of you. Thanks for joining me on this journey through time and space. If you enjoyed this cosmic story, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure into the wonders of science. Let me know in the comments what part of the universe's story fascinates you the most. Thanks for watching.